Okay, so in the last week, we start the unit number 2, theory of discrete mathematics, and the unit name is the lattices. And in this unit, let's discuss the types of relation in the last lab. The first definition is the power set, then after product set.
Hello.
Yes,
Uh,
yes, through it. Okay. Yes, through it. Any problem?
no, sir. No, sir.
Okay. And after that, types of relation. There are 4 types of relation, and relation means subset of A cross A, that is called the relation. First type is the reflexive, and how we can check the reflexive. So for every element of a given set, if A or A is satisfied, we can say that this relation is known as a reflexive. Then after symmetric, these are the 2 examples of reflexive. Second relation is symmetric, means if AB belongs to R, then BA should also belongs to R. And then after antisymmetric, for A not equal to B, 2 element from the given set, A not equal to B, and if AB belongs to R, then BA does not belongs to R. Okay, that is a case of antisymmetric relation. And after that, the few example was discussed. Next part is the transitive relation, and if AB belongs to R, BC belongs to R, then based on these 2 relation, A comma C should also belongs to R. And this examples, and based on this relations, we can define the equivalence relation. And what is the definition of equivalence? If it is satisfied the 3 relations, reflexive, symmetric, and transitive, then such relation is known as the equivalence relation. Okay, for this given relations, given set, we have to satisfy reflexive condition, symmetric, and transitive, then we can say that this formation means the given set and the given relation is known as the equivalence relation. And these are the few examples related to the equivalence relation. First, you have to check the reflexive, then after symmetric, and then after transitive. Okay, if all these 3 conditions satisfy, then we can say that this Z with the relation is known as a equivalence relation. Okay? And was discussed the few examples related to this topic, and some practice was done in the last lab. And then after the partially ordered set, we will discuss definition and one counter example. And let us revise it again. And then after we'll discuss some few examples related to the partially ordered set. So how we can define partially ordered set? If the relation R for the given set A, and if it is satisfy the reflexive, antisymmetric, and transitive condition, okay, on A, means A is a given set, that then AR is known as a set, means a partially ordered set. And it is a notations for that. This bracket is considered as a partially ordered set of A and R. Okay, A to the R. A is a given set there. Any set will be there, and then after R is any relations we can define. Okay, we can consider that. So you have to say it is a poset or not. So how we can say it is a partially ordered set? So first you have to check the reflexive condition, then after antisymmetric, and then after transitive. Okay, and what is the difference between equivalence and partially ordered set? In equivalence relation, the relation should be symmetric, that okay, reflexive, symmetric, and transitive. But in partially ordered set, we'll check that reflexive, antisymmetric, and transitive. Okay, so this is the difference between equivalence relation and the partially ordered set. And here one counter example is given, that for A is equal to ABC, and here one subset is considered from A cross A. Okay, the 9 pair will include in the A cross A, and I consider the 6 pair which is mentioned in the R, and which is a subset of A cross A. We can say it is the relation. And now let us check it is a partially ordered set or not. Means we'll check that it is a reflexive, antisymmetric, and transitive or not. So here it is a reflexive. Why it is reflexive? The condition of reflexive we have, for every a belongs to A, means let us consider another notation. Every x belongs to A, we'll check that x comma x belongs to the R. Okay, x comma x belongs to the relation. So there are three entry A, B, C. Okay, so for every x belongs to A, means for A comma A is exist here. For a B, x equal to B, so B comma B is also exist as a second pair, and for x equal to C, so C comma C is also exist here. So this relation is satisfy the reflexive condition for every element of the domain, for every element of the given set. The x comma x should belongs to the R. So if it is satisfied, then we can say that it is reflexive relation. And then after antisymmetric, the condition of antisymmetric is here. For AB belongs to R, for XY belongs to R, this implies YX does not belongs to R. ठीक है, अगर XY R के अंदर है, then YX does not belongs to R. This is a case of antisymmetric relation. So now check all this pair. There are 6 pair is given here in this R. And now for all this pair, if XY is defined in the R, then YX should not belongs to the R. So for A comma B, okay, XY as a AB, then B comma A is not exist here. Okay, means it is not given in the R. Okay, so for this pair, the antisymmetric condition is satisfied. Now B comma B. So as we know that A comma A, B comma B, C comma C, that three pair are considered as a symmetric as well as antisymmetric form. Okay, so by default that is a symmetric as well as antisymmetric form we'll consider. Which pair? A comma A, B comma B, and C comma C. Okay, so this is antisymmetric, this is also antisymmetric. Now A comma C, so here C comma A is not exist. Okay, and now B comma C, so C comma B is also not exist. Clear? So for all such pair, if xy belongs to R there, then yx does not belongs to R. Therefore, this relation is also satisfy the antisymmetric condition. And now third one is a transitive. So how we can check the transitive relation? If xy belongs to R, yz belongs to R, this implies x comma z also belongs to R. Okay? If this two pair R exist, means xy, yz, y should be the same, then we have to create xz, then xz should also belongs to R. Okay? So now identify such pair as a AB comma A comma B, and second pair I consider B comma B because y is the same that A comma B and B comma B. Here xy, yz. Okay, so what is the xz? That is the A comma B will get, and A comma B is also exist here. And then after you can consider A comma B and the B comma C. Here B is a common, y is a common here, so it will create A comma C form, and A comma C is also exist as a fourth pair. Clear? So for all such possibility as x, y, y, z, okay, x comma z also exists in such R. Okay, so it is also satisfy the transitive relation. So it is reflexive, antisymmetric, and transitive. So we can say that A comma R is a partially ordered set. Okay, so this way we can verify the is it partially ordered set or not. You have to just check that reflexive condition, antisymmetric, and transitive. Okay. And for this definitions, was consider this example in the last lab. Z less than or equal to is a partially ordered set or not. Okay, relation is given that less than or equal to, and Z is the set of all integer which can include the all negative infinity to positive infinity. Okay, so this number are included in the Z, and relation is less than or equal to means for xy belongs to Z, x or y if x less than or equal to y. Okay, means xy belongs to R, means x or y if x less than or equal to y. So the pair you can consider 0 1, okay, 0 2, 0 3, minus 1 0, okay, minus 2 0, minus 2 minus 1. So this pair you can consider as a in the relation which satisfy the x less than or equal to y. So now let us check it is reflexive, antisymmetric, and transitive or not. So for reflexive case, we'll check that for every x belongs to z, x comma x belongs to r or not. Okay, for every x belongs to z, x comma x belongs to r or not. So x comma x, here it is xy, it belongs to r if x less than or equal to y. So when we say that x comma x belongs to r, if it is satisfy x less than or equal to x, then we can say that x comma x belongs to r. So for every x belongs to z, we can easily say that 1 less than or equal to 1, 2 less than or equal to 2, 0 less than or equal to 0, minus 1 less than or equal to minus 1. Why it is a true? Because the equality is mentioned here. If we remove the equality, then it is a wrong. Okay, then it is not satisfy the reflexive condition. But here it is the equality is given that less than or equal to. Okay, that is read as less than or equal to. Therefore, it is a true. But when I remove the equality, let us remove that. So now that relation is not satisfied the reflexive relation. Clear? But here is equality is given that, therefore it is a true. So here x less than or equal to x, so that we can say x are x, and therefore less than or equal to is satisfy the reflexive relation on z. And now second one, that is a antisymmetric. For x not equal to y, okay, if xy belongs to r, then yx does not belongs to r. ठीक है, ये आपको प्रूव करना है. अगर एक्स वाई आर के अंदर है तो वाई एक्स मीन्स उसका सिमेट्रिक फॉर्म आर के अंदर नहीं होना चाहिए. तो व्हाट डज इट मीन? फॉर एनी टू नंबर कंसिडर फ्रॉम द z, if it is not equal to y, x not equal to y, and if x less than or equal to y, so we cannot say y is also less than or equal to x. Means that is not a true. Okay, and that is required to say yx does not belongs to r, because when we can say that y does not, yx belongs to r, if we can write y less than or equal to x, then we can say that yx belongs to r. But here for x less than or equal to y, we cannot say y is also less than or equal to x. Okay, that is a true only for one case, if x and y are the same. But here the condition is given that x not equal to y. For this case, you have to check that can we say it is a true or not. So consider any counter example for that. Let us take 1 less than or equal to 2, that is x less than or equal to y. So we cannot say 2 is also less than or equal to 1. Okay, that is not a true. Means the 2 comma 1 does not belongs to r, and that is required to say it is antisymmetric. Means here it is given that x less than or equal to y, then y can't less than or equal to x. Okay, and therefore we can say that yx does not belongs to r. Okay, x y r के अंदर है, but yx does not belongs to r, and therefore less than or equal to is satisfy the antisymmetric condition, and therefore we can say that it is an antisymmetric relation. Okay, and then after third one, for xy belongs to r, yz belongs to r, then we'll check that xz also belongs to r. So for xy belongs to r, we can say that x less than or equal to y, and for yz belongs to r, we can say that y less than or equal to z. Now observe these two conditions, x less than or equal to y less than or equal to z. So based on this two condition, we can also say that x less than or equal to z. ठीक है, क्योंकि x लेस देन और इक्वल टू y है, y इज अ बिगर वैल्यू देयर, और y से बिगर वैल्यू z है. ठीक है, वी कैन इजीली से दैट x इज आल्सो लेस देन और इक्वल टू z. ठीक है, फॉर एग्जांपल यू कैन कंसीडर 1, 2 and 5. Okay, x y z, that is 1 less than or equal to 2, 2 less than or equal to 5. So we can easily say that 1 is also less than or equal to 5. Okay, that is true for any x y z. If it is satisfy x less than or equal to y less than or equal to z, then we can easily say that x is also less than z, and therefore it satisfies the transitive, and therefore we can say that if it is satisfy all these three conditions, reflexive, antisymmetric, transitive, then we can say that z less than or equal to is a partially ordered set. Okay, so this example was discussed in the last lab, and then after we was discussed one important result, and based on this result we'll define the next example, and this result is here. Sn means a set of all divisor of n, and here one example is given that S12. So The values include their 1, 2, 3, 4, 6, 12. These are known as a divisor of the 12. Okay, because we can divide 12 by 1, we can divide 12 by 2, then after 3, 4, 6, and 12. Okay, so these are the number which have in this set theory, which is divide to the 12. Okay, so 1, 2, 3, 4, 6, 12. And if we consider another value, let us take a 15. So how many values are divisor of 15? First is a 1, then after 3, then after 5, okay, and then after 15. Clear? So these are the divisor of 15. Consider another value. Yes, let's take a 20. So divisor of 20 will be 1, then after 2, then after 4, okay, then after 5, 10, and 20. Clear? So these are the divisor of 20. So just consider the positive value, and for which value we can divide the given number. Okay, so this number are considered as a divisor of the given value. Clear? And based on that, we'll define one new relation. Clear? That is known as a divide relation. Okay, D is known as a divide relation. And how we can define it? If A divide B, then it is considered as a D B. What is meaning of that? A divide B. So for counter example, we can consider 2 divide 6. 6 को आप 2 से divide कर सकते हो. So you can write the 2 divide 6. Okay. Then 5 divide 30. 30 को आप 5 से divide कर सकते हो. So we can consider 5D30. Okay. But we cannot consider a 2D3. Okay. That is not true because 3 को आप 2 से divide नहीं कर सकते. ठीक है. We cannot consider 4 divide 6. Clear? But we can consider 3 divide 6. We can consider 3 divide 12. We can consider 4 divide 12. Clear? But we cannot consider 3 divide 4. Clear? 4 divide 6. Okay. So this is meaning of that one. That is known as a set of divisor. And by using these conditions, we'll check the next questions of this theory, partially ordered set, and that is given here n comma d. So check whether n comma d, n is a set of natural number and d is a divide relation, is a partially ordered set or not, where d is the divide relation. Okay, so n include the natural number is given here 1, then after 2, 3, 4, and so on. Clear? This is a natural value or perfect number that. And d is a divide relation. So what does it mean? For xy belongs to n. Okay, xy belongs to n, and we can say that xy belongs to the relation if x dy. Okay, let us use another notation, a and d. Xy is also the similar one, that a comma b belongs to r. Then we can say that x a comma b belongs to r if a d b. Okay, a d b. A b belongs to r if a divide b. So which pair you can consider? We can consider 1 divide 2. We can consider 1 divide 3. We can consider 1 divide 4, 2 divide 4, 2 divide 6, 4 divide 8, okay, 3 divide 9, 3 divide 6, 3 divide 12. So this pair you can include in the relation which follow the divide relation. Okay, but we cannot consider 2 divide 3. We cannot consider 3 divide 4. Okay, we cannot consider 4 divide 9. So this pair we cannot consider as a relation. So let us check it is a partially ordered set or not. First we'll check the reflexive condition, then after antisymmetric, and then after transitive. So in the reflexive conditions, we'll prove that for every x belongs to n, we'll check that x comma x belongs to r or not. Okay, x comma x belongs to r or not. And here I consider that x is equal to 1 star x. For any x belongs to L, x is equal to 1 star. So what is meaning of that? When we consider x dy form, okay, x divide y, clear? We can consider the formula as a y is equal to m into x. Y is equal to m into x, where m belongs to the natural number. Clear? This is a formula of x divide y. when x divide y, we can consider y is equal to mx, product of two number. X is already given that, and m you have to choose from the set of natural line. So m into x. For example, if we consider a 4 divide 12, okay, 4 divide 12. So 12 we can write as a 12 we can write means y we can write as a 3 into 4, where 3 belongs to the set of natural line, okay, set of natural number. That is the value of m, 3 into 4. Clear? Y is equal to m into x. So here I consider x is equal to 1x. What does it mean? Here you have to prove that x comma x belongs to R or not. Means we can say that x dx or not. Clear? X divide x or not. What does it mean? We can consider x is equal to a 1 into x, where 1 belongs to the natural number. Clear? That is a true. We can consider 1 is x is equal to 1 into x. Okay, y is equal to mx. So what does it mean? X is equal to 1 into x. We can easily consider a 1 belongs to set of natural line which satisfy the result. Okay, so therefore we can say that satisfy the reflexive relation, and we can also say that by using this condition x dx means 1 divide 1, 2 divide 2, 3 divide 3, 4 divide 4. That is always a true that. So based on this condition you can also write the conclusion that okay, this satisfy the reflexive relation. Okay, so here x dx, and therefore we can say that d is a reflexive relation on n. Okay, so first condition is a true, and now in second condition we'll check that anti-symmetric condition. So what is anti-symmetric condition? For xy belongs to R, we'll check that yx does not belongs to R. Okay, that is a condition of anti-symmetric. So we can easily say that x divide xy belongs to R means x divide y. Then we cannot say y is also divide x. Okay, that is not a true. Why? Because if we consider a 2 divide 6, okay, that is a true. So we cannot say 6 is also divided 2. Okay, that is not a true. Means 6 can't divide 2. That y can't divide x. So that is required. Means yx does not belongs to R, and therefore we can say that it is the anti-symmetric relation. But here it is a proof by using the formula. If x dy, then we can say that y is equal to x into z, and we can also consider m into n form. If we consider remove the z here, we can consider here m into x, where m belongs to the set of natural line. Okay, m belongs to n, y is equal to mx, n belongs to n. Okay, but x dy, then we cannot say y dx, means y can't divide x, and therefore yx, okay, y can't divide x. And what does it mean? Yx does not belongs to R, and therefore we can say that d is a satisfy the anti-symmetric relation, and therefore we can say d is the anti-symmetric relation on the set of natural line. And then after third one, transitive condition. So what is the transitive condition? If x y belongs to R, y z belongs to R, then we will check that x z belongs to R or not. Okay, so x y belongs to R means x dy, y z belongs to R means y dz. Then we'll check that x dz or not. Okay, so we can consider any counter example for that, and we can easily say that that is always a true. But let us prove by using the formula it is a true or not. So x dy means we can write y is equal to mx. Okay, for x dy formation, x dy, we can consider y is equal to mx, where m belongs to n. And for y dz case, we can write z is equal to n into y, where n belongs to set of natural number. Okay, and we'll prove that x dz or not. Okay, so here we have the two formula. Y is equal to mx, that is the formula number 1, and z is equal to ny, that is the formula number 2. Okay, so use the equation number 1 and replace the value of y in the equation number 2. Okay, that is given that here z is equal to ny. So replace the value of y there and derive a new equation in form of z and x. So here we get z is equal to ny, that is equation number 2, and replace their value of y. So we get n into mx. Okay, z is equal to ny is given there, and just replace value of y. So y here is m into x. So we get n into m into x, and now combine the constant value m and n. So it is mn into x. Okay, mn into x, and as we know that m comma n belongs to n. ठीक है, दोनों वैल्यू n के अंदर है, तो उसका प्रोडक्ट जो होगा m क्रॉस n, दैट इज ऑल्सो बिलोंग्स टू n. ठीक है, इफ यू कंसिडर m इज इक्वल टू 5 and n is equal to 3. ठीक है, so m into n also, that is a 15 that, and 15 is also belongs to set of natural number. ठीक है, तो प्रोडक्ट भी n के अंदर ही होगा. व्हाट इज मीनिंग ऑफ दैट? We prove that z is equal to mn into x, where mn belongs to n. So based on this formula, we can say that x dz, okay, x dz. Why we can say that? Because we prove here z is equal to, if you consider this is a value, one constant value belongs to set of natural number into x. What does it mean? We can consider x divide a z, means x dz, and that is required to say it is a transitive. If x dy, y dz, then we'll check that x dz. So therefore, we can say that D is a transitive relation on N, and therefore we can say that N comma D is a partially ordered set. Okay, N comma D is a poset. Why it is a partially ordered set? Because it is satisfy the reflexive relation, it is satisfy antisymmetric condition, and third one is a transitive condition. It is satisfy that. Therefore, we can say that N is a set of natural number with the divide relation, that is the partially ordered set. Okay, so this is the second example based on the divide, and we can easily say that that is also the partially ordered set. Okay, so now in the question number 3, the proof is not mentioned in the PPT. Then after question number 4, 5, and so on. Okay, so you just write out in your book. Otherwise, after completion of this proof, okay, I will write all this important concept here. So just take it screenshot for your reference. How we can prove this, means how we can solve this example. Okay. So ZR is a poset or not? Third question, ZR. Z means set of integer, R is a relation, and relation is defined here. For AB belongs to Z. Okay, Z is given that -3, -2, -1, 0, 1, 2, 3, and so on is Z. And now for AB belongs to Z. Okay, for AB belongs to Z, AB belongs to R, means ARB. Okay, if when we say that AB belongs to R, means ARB, if A can be write as a B raised to N. Okay, two number consider from the Z. Okay, and when we say that the pair AB belongs to A comma B belongs to the relation, if A can be write as a B raised to N, A can be write B raised to N, where N is a, N should be positive integer, positive integer, means it should be the positive perfect number. Okay, 1, 2, 3, 4, 5, and so on. The power should be the perfect number, that we cannot consider 1 by 2, 0.5, 0.6, and so on. Clear? So which pair we can consider? We can consider 4, 2. Okay, check the 4, 2 as a AB, that is belongs to Z. So 4, 2 can be considered as a 4 is equal to 2 square. where 2 belongs to set of natural number means it is a positive integer. Okay, is it true? 4 comma 2 belongs to R. Clear? Then after you can consider 9 comma 3. Lots of possibility that. Okay, so this pair are included in the relation, and we'll check that it is the partially ordered set or not. Means we'll check that it satisfies reflexive, antisymmetric, and transitive condition or not. Okay, so let us prove the first one. Reflexive condition. So reflexive means okay, for every uh, A belongs to Z, we'll check that A comma A belongs to R or not. Okay, for every X belongs to Z, we'll check that A comma A belongs to R or not. So how we can say A comma A belongs to R? If it is satisfy the condition A is equal to B raised to N. Here B is also A. So if we can write A is equal to A raised to N for the positive integer N, A is equal to A raised to N, where N should be the positive integer, which N we can consider, which satisfies the result as A is equal to A raised to N. That is only one value we have, N is equal to 1, and 1 is also the positive integer there from the natural line from the set of integer. Okay, A is equal to A raised to N, and we can consider N is equal to 1 to say it is a true form. Okay, and N is equal to 1, that is also the positive integer, so it is always a true for any value of N, and we can consider that is this relation is satisfied the reflexive relation. Okay, so for every A belongs to Z, A comma A belongs to R, that you have to check that. So we can consider A comma A means A is equal to A raised to 1. Okay, here it is A comma B, that is here A is equal to B raised to N. So for A comma A case, we can consider A is equal to A raised to 1, where 1 is the positive integer that. Okay, 1 is the positive integer, 1 is positive integer. Therefore, we can say that A comma A belongs to R. Okay, and you can consider every A belongs to Z. Let us take a 5. 5 belongs to Z. So can we say 5 comma 5 belongs to R? That is a true. Why it is a true? Because we can consider 5 is equal to 5 raised to 1. Okay, 5 is equal to 5 raised to 1. That is A is equal to B raised to N, where N is equal to 1 and A and B are the same. 5 is equal to 5 raised to 1. Yeah, that is a true. 9 is equal to 9 raised to 1. 10 is equal to 10 raised to 1. So for all such number from the Z, reflexive condition always satisfied. Okay, so therefore R is a reflexive. Okay, the first condition is satisfied. Now second one, antisymmetric. So in antisymmetric, we'll check that if AB belongs to R, this implies B comma A does not belongs to R. ठीक है, अगर ए बी आर के अंदर है मीन्स ए इज इक्वल टू बी रेस टू एन है, तो बी कोमा ए, तो बी कोमा ए की फॉर्मूला क्या होगी? इफ यू कंसिडर बी कोमा ए, देन फॉर्मूला विल बिकम बी इज इक्वल टू ए रेस टू एन. ठीक है, बी कोमा ए बिलोंग्स टू आर मीन्स यू कैन कंसिडर बी इज इक्वल टू ए रेस टू एन फॉर्म, and if it is a true, then we can say that BA belongs to R. But here we'll check that BA does not belongs to R, means that this formula should not be true that. So let us check that it is a true or not. So start with AB belongs to R. Okay, for AB belongs to Z, AB belongs to Z, A not equal to B, and here AB belongs to R is given that this implies A is equal to B raised to N, where N is a positive integer. Okay, N is the positive integer, and will हमें प्रूव क्या करना है, B कोमा डज नॉट बिलोंग्स टू R. तो अगर लेट अस से B कोमा बिलोंग्स टू R है तो उसकी फॉर्मूला क्या बनेगी कि आपको प्रूव करना पड़ेगा कि B कैन बी राइट एज A रेस टू N. ठीक है, B कैन बी राइट एज अगर बी ए की फॉर्मूला में बनाते हैं तो बी कैन बी राइट एज ए रेस टू, ये आपको प्रूव करना पड़ेगा फॉर एन इज अ पॉजिटिव इंटीजर. बट लेट अस से इट इज नॉट ट्रू फॉर एनी केस. So how we can prove that? Here we have a is equal to b raised to n, and we need here b only. Okay, so remove the power n from the b. So how we can remove the power n? So apply the nth root both side. ठीक है, दोनों साइड आपको nth root अप्लाई करना है. तो here we get nth root means 1 upon n आपको दोनों पावर पे अप्लाई करना है. ठीक है, दोनों जगह. So here we get a raised to 1 upon n, and when we apply 1 upon n to here, n will be removed. ठीक है, because we get n into 1 upon n form. So here we get only b. ठीक है, and let us write this as a b is equal to a raised to 1 upon n. b is equal to a raised to 1 upon n. So here we get one form b is equal to a raised to n type. ठीक है, but in place of n we have the 1 upon n. Okay, in place of n we derive a 1 upon n. b is equal to a raised to 1 upon n. So here we have n is a positive integer at the starting. Positive integer. Integer word is very important for this case. If I remove the integer word, then it is not anti-symmetric here. But integer word is very important here. Based on that, we can say that b comma a does not belongs to R. Why it is does not belongs to R? Because here we have AB belongs to R, means A is equal to B raised to N if N is a positive integer. A is equal to B raised to N if N is a positive integer, and here we get B is equal to A raised to 1 upon N. So we cannot say B comma A does not belongs to R. Why? Because यहाँ पे n positive integer है, तो here we cannot say 1 upon n is also the positive integer. Why? Why 1 upon n is not positive integer? वो positive होगा but it never will be the integer that. ठीक है, यहाँ पे आपने 2 लिया है. ठीक है, a is equal to b square let us take. So we cannot say 1 by 2 is also the integer. ठीक है, we cannot say 1 upon 5 is integer. Clear? So if n is integer, then we cannot say 1 upon n is also the integer that. ठीक है, so here 1 upon n is not integer. ठीक है, 1 upon n is not a integer, and therefore we can say that b comma a does not belongs to R. B comma a does not belongs to R. Why it does not belongs to R? Because we get one form b is equal to a raised to 1 upon n, and here we starting we consider n is a positive integer, so we cannot say 1 upon n is also a positive integer, and for this positive integer we can consider b is equal to a raised to n form, but here we get 1 upon n form. तो फॉर n पॉजिटिव इंटीजर आप कंसिडर करते हो तो 1 upon n और पॉजिटिव होगा बट इंटीजर नहीं होगा. ठीक है, so therefore we cannot say ba also belongs to R, and therefore we can consider ba does not belongs to R, and therefore that is required to say it is anti-symmetric. If AB belongs to R, then ba does not belongs to R, and therefore we can say that R is a anti-symmetric relation. Okay, so second condition is satisfied, and now let us check the third one. Just 1 minute. Third condition is the transitive. So we have the relation is there in the transitive. Okay, if ABC belongs to Z, if AB belongs to R, BC belongs to R, this implies A comma C also belongs to R. ठीक है, ये आपको प्रूव करना है. तो AB belongs to R, BC belongs to R. So what does it mean? So when we say AB belongs to R, A can be write as a B raised to n, where n is a positive integer. ठीक है. And now for BC belongs to R. So when we say BC belongs to R, if B comma C belongs to R, means B can be write as a C raised to m, where m is a positive integer. ठीक है. So by using this proof formula, we'll check that A comma C also belongs to R. Means हमें prove क्या करना है कि A can be write as a C raised to any power which is a positive integer. Okay, C A is equal to C raised to any power. Okay, कोई भी power आप consider कर सकते हो, which should be the positive integer. ये आपको prove करना है by using this two formula. One and second formula we have B is equal to C raised to m. ठीक है. To use this both formula and consider as a one equation. So here we have A is equal to B raised to n and B we have C raised to m. So just replace value of B in the equation number 1. So we get A is equal to C raised to n with the power C raised to m with the power n. Okay, B की वैल्यू आपको इक्वेशन 1 में रिप्लेस करनी है. ठीक है, रिप्लेस द वैल्यू ऑफ B फ्रॉम द इक्वेशन नंबर 2 to the equation number 1. So we get A is equal to C raised to m, and here we have the power is n. So power with the power, what does it mean? तो उसका क्या होगा, प्रोडक्ट होगा. ठीक है, mn. A is equal to C raised to mn. So here we consider n is a positive integer, m is also positive integer. So here we have its product m into n. So product also will be the positive integer. ठीक है. If we consider m is equal to 5, n is equal to 3, both are positive integer. So m into n, that is a 15, and 15 is also the positive integer. ठीक है, you will never get a non-integer value there. So m into n is also positive integer. So here we prove that A is equal to C raised to mn. What does it mean? We can say that A comma C belongs to R. Okay, and that is required. So we can say that R is a transitive relation. Okay, R is a transitive relation. And what does it mean? Okay, the form is given that Z ZR is poset. Okay, conclusion is that ZR is the partially ordered set. Okay. So is there doubt to anyone in this question? The solution is not mentioned in this PPT, and when we upload in your login ID, solution not will be there. So just take it the screenshot of this solution, how we can solve that in your mobile, otherwise in laptop. Otherwise, write down the main topic, main point in your book, and this is for your reference how we can prove that. Okay, so this is reflexive first condition, then after second one anti-symmetric, and then after the third one transitive. Okay, so these three conditions you have to verify to say it is a partially ordered set or. Okay, so take the screenshot for the and after the second one. And for any doubt, you can ask me. That is the second one. Okay. Good. So is there any doubt in the topic of partial order set and these three example? Yes. Is there any doubt to anyone? Okay. So next question is there. Uh, Let us prove first for S30D, and then after we'll discuss for S60D. Okay. So S30D, S30 means set of divisor, and D means the divide relation. And let us check it is partially ordered set or not. So first we'll check that S30 means how many values will include in the S30 set. Okay. So first number will be 1 because 30 को आप 1 से divide कर सकते हो. Then after 2, 3, then after 4 will be not there, 5, 6, 7, 8, 9, then after 10, 15. Okay, and now directly the 30. Clear? So 8 number will be included in the S30 set, which are known as a divisor of 30. Clear? So first we'll create this there, and then after we'll check it is satisfy the 3 condition or not. And here divide relation is given that. What is meaning of that? For AB belongs to S30. ठीक है, कोई भी दो नंबर आप ले लो S30 में से. AB belongs to R. Okay, when we say AB belongs to R, if A divide B, ठीक है, A divide B, if it is satisfied, then we can say that A comma B belongs to R. Means which example you can consider? We can consider 2 divide 6, okay, 2 divide 10, 1 divide 3, 1 divide 5, 5 divide 10, 5 divide 15, 5 divide 30, 10 divide 30, 6 divide 30, and so on. But we cannot consider 6 divide 10. We cannot consider 5 divide 6. We cannot consider 3 divide 5. We cannot consider 2 divide 3. Okay, so this pair will not include in the relation, but the pair which follow the relation, this pair we can consider in the set. Okay, so these are the pair we have which satisfy the divide relation, and now let us check that it is satisfy the reflexive condition or not. first condition, reflexive. And we have that for every A belongs to S30, we'll check that A comma A belongs to R or not. Okay, A comma A belongs to R or not. So A comma A belongs to R means we can easily write that if we apply the formula y is equal to mx form, then we can easily consider A is equal to A raised to means 1 into A. Okay, and therefore we can say that A D A. तो कोई भी नंबर आप ले लो S30 में से 1 divide 1, 2 divide 2, 3 divide 3, 5 divide 5, 10 divide 10, 15 divide 15. That is always a true. Okay. So therefore, for every A belongs to S30, A comma A is always belongs to R, and therefore we can say that divide relation is satisfy reflexive relation on the set is given that S30. Okay, so first relation is complete, and now let us check the second relation, anti-symmetric relation. So condition of anti-symmetric, we have for A not equal to B, if AB belongs to R, this implies B comma A does not belongs to R. Okay, and now let us prove it. We cannot say BA also belongs to R. Means we have AB belongs to R. This implies A divide B. So for any case, if A divide B, then we cannot say B is also divided. Okay, means B can't divide A. Clear? And you can also write in this word B can't divide A. Okay? And therefore we can say that B comma A does not belongs to R. Okay, and therefore we can say that B can't divide A, and therefore we can say that B comma A does not belongs to R, and therefore we can say that D is anti-symmetric relation on S30. Okay, the second condition is also satisfied, and now let us check the third one, a transitive. So let us prove the transitive condition. Okay, for ABC belongs to S30, AB belongs to R, BC belongs to R. This implies A comma C also belongs to R. Okay. So AB belongs to R means A divide B. BC belongs to R means B divide C. And we can also prove by using the formula that we discussed in the example. Okay, A divide B means we can write B is equal to X into C. X belongs to set of natural number, and here C can be write as a Y into B. Okay, where Y belongs to set of natural number. Okay, here XY belongs to N. And now combine one equation, C can be write as a Y into X into C. Okay, replace a B here, so we get here X into Y into C. So here it is a X into A. and here we get also a x into a, and that is a. Clear? So C is equal to x into y into a. Just arbitrary notation I use here, x, y. You can also consider mn, pq, rst, anyone. Okay. So xy also belongs to set of natural number that we already discussed, and therefore we can say that a comma c, if c can be written as x into y into a, means a c comma a means a comma c also belongs to set of natural number, means also belongs to a relation. So if it is reflexive, antisymmetric, transitive, then we can say that it is a partially ordered set. And we can consider also the counter example for that. Here for antisymmetric case, we can consider if 5 divide 10, okay, that is a true, but we cannot say 10 is also divide 5. Okay, in any case, 10 does not divide a 5. Therefore, it is antisymmetric relation. And now for here in transitive case, if we consider a 3 number, 5, 10, 30. 5, then after 10 and 30. 5 divide 10, that is a true. 10 divide 13, that is also true. Okay, x divide y divide z, a divide b divide c. Then we can also say that 5 is also divide 30. Okay, 10 divide 30. Then we can also say that 5 is also divide 30. Clear? So any counter example you can include there in this condition. For this case, we can prove that that is also transitive, it is antisymmetric, and it is also reflexive. Okay. So you can also include a counter example in the solution. That is a general idea we consider here. For any number, for any xy, we can prove it. But you can consider a counter example which is number are 8 number only. We can easily make a pair for any 2 number, and we can easily check that if this condition is valid or not. Okay, so for any such pair, we can easily prove the each condition: reflexive, antisymmetric, and transitive. Okay, so this is a proof of the solution of this example. You just take a screenshot for your reference. How you can prove it? Just take the screenshot. S30D, and if we consider S60, okay, in place of S30, if consider S60, so same argument we have to consider here for reflexive, antisymmetric, and transitive, and that is also the partially ordered set. Okay, any set n z q r, n z q r, and then after consider S30, S25, S40, S90, S100, any set consider that with the divide relation. So it is always a reflexive, antisymmetric, and transitive. Okay, the same argument you have to consider for the divide relation, and you can easily say that it is also the partially ordered set. Okay, so just try it for S60D. Okay, how many number are included in the S60, and can we prove it is a reflexive, antisymmetric, and transitive or not? Okay, means it is a partially ordered set or not. So just try it by yourself for S60 comma D. Okay, this is solution of S30. So take the screenshot for your reference. Otherwise, just write down the main point in your book how we can prove it. Okay. Now, next question is there. Z comma D. So first try it by yourself how we can prove that Z comma D is a partially ordered set or not. And that is a similar one, S30 comma D. Okay, S30 comma D. Z comma D. That is similar pattern here. Okay, just set is changed. In place of S30 we have the Z. We will apply the similar argument to check it is the reflexive, antisymmetric and the transistor. Okay, just try it by yourself. For in doubt you can ask me, and then we'll write the solutions here. Okay, first check the reflexive condition. So can we say this relation satisfy the reflexive property? And Z means minus infinity to infinity. Okay, and relation is here divide. So for any AB belongs to Z, AB belongs to the relation, AB belongs to R means relation if A divide a B. Okay, so just write that is similar to the previous one. Okay, Okay, is it done? Is there any problem, any doubt? यस, कंप्लीट हो गया। आयुष, दर्शन, प्रतीक, नैन्सी, श्याम, उत्सव, सूर्यबली,